All right, this video, section 1.2, kind of follows along with section 1.1, where we were dealing with linear equations. This section is dealing with the applications of linear equations, sort of, applications in the real world. So some basic steps when you're trying to solve these real world problems is, first of all, read the question carefully. Assign variables to unknowns. That's always a good idea, right? If you can use a table or a drawing, express the unknowns in terms of other variables, right? So just try generally, these are some good rules to follow. Write some equations using some of the variables or variable expressions that you kind of were developing in step 2. You want to solve those equations, and then you want to state the answer, right? And then also ask yourself, does this sound reasonable? Right? If you're asked for how much interest do I get when I put $10 in the bank for a couple of years and you get $3 million, that's not a reasonable answer, right? So does the answer seem reasonable, right? And you can check your answer sometimes too. Okay, so let's look. First one example that we're going to do has basis in geometry. All right, the length of a rectangle is 2 inches more than its width. If the length and the width are each increased by 3 inches, the perimeter of the new rectangle will be 4 inches less than 8 times the width of the original rectangle. Now that sounds overwhelming when you first read it, right? Read it a couple times maybe, but then you want to sit down and think, maybe draw a picture. Label the sides with this expressions based on the information we know, right? We're talking about 2 different rectangles, so maybe we draw 2 different rectangles. So we draw a rectangle, and it may not be to scale because I'm not sure of the details yet, right? I don't know what shape this has. If I did, I would be done, right? So you may not draw something that's perfectly to scale, but generally, if it's a rectangle, one length is longer than the other, right? Okay, and then also think about it. So this is the one rectangle, and then it says, if the length and width are increased by 3 inches. Okay, so that means the next rectangle should be longer and wider. Like, I don't know if I'm drawing it to scale, but that's okay. It's just it's a picture to help us visualize what's going on. Okay, so let's look. The length of the rectangle is 2 inches more than its width. Okay, so let's call this the width. And, generally this is considered the length. So what expression could I use to label this side? The length of the rectangle is, you could say L if you wanted, but could we use this to say an expression in terms of W, the width? The length is 2 inches more than the width, so I could say width plus 2. Okay? That's the first rectangle. Now, if the length and the width are each increased by 3. All right, so what could I call this? I could call this W plus 3. And I could call this what? It's this one, but I've increased it by 3. So this could be W plus 5. Okay? Now, the perimeter of the new rectangle will be 4 inches less than 8 times the width of the original. So let's think about that. The perimeter, right? Try to write an expression or an equation. The perimeter of the new rectangle. So that's talking about this one here, the perimeter of this. That's the distance all the way around. Remember, perimeter. So the perimeter of the larger rectangle will be, or is equal to, 4 less than 8 times. So 4 less than 8 times something, times what? Width of the original. And so that's the width of the original. W doesn't refer to this. W is the width of the original. So I've based everything on this length. Okay, does that make sense? So read that again. The perimeter of the new rectangle will be 4 inches less than 8 times the width of the original rectangle. So something like this. Now, P. What is P? Well, P, that's the perimeter of this one. So how could I write that in expressions? Well, it's these 2 things, but doubled, right? Because this one's down here, this one's also over here. So instead of P, I could write 2 times w plus 5 plus 2 times w plus 3. That's doubling the two lengths, so that's the perimeter in terms of w. And of course, that's equal to 8w minus 4. All right, so we just need to solve this equation. Okay, makes sense? And so I'm going to distribute the 2, so I get 2w plus 10 plus 2w plus 6 equals 8w minus 4. Combine these, that's 4w minus 16, plus 16 equals 8w minus 4. Now, in this case, this w is bigger, so I'm going to move this 4w to the right and move this negative 4 to the left. All right, so when I bring that over, that gives me 8w minus 4w, that's 4w. And I'm going to add 4 to both sides, that's 20. Okay, so I'm going to divide through by 4, and w must equal 5. So the original width of this thing is 5. Now, you got to make sure that you're actually answering the question, right? So don't just box this in and say, yay, that's my answer, because we want to make sure we're answering the question they're asking. So find the dimensions of the original rectangle. Okay, so we found w, the width of this thing is 5. And then the length of the original rectangle is 7. So make sure that you're actually answering the questions. Length of 7, because I'll look up here, right? The length is 2 more than the width, so that's got to be 7. Okay, and then you can plug that in to make sure that it works in the original one. That wouldn't be a bad thing to do. Okay. All right, let's look at modeling. All right, if a vented range hood in a kitchen removes contaminants such as carbon monoxide and nitrogen dioxide from the air at a rate of F liters of air per second, then the percent P of the contaminant that are removed from the surrounding air can be modeled by the linear equation below, where F, which is the basically the liters per second of air that's being filtered, is between 10 and 75 liters of air per second. Now, this was a kind of a weird situation in which I think the percent is listed when you say put percents in here. Kind of a weird case. Most of the time, if I said something like 65%, we would always enter that as 0.65 almost exclusively. But for this formula, it's kind of weird. This P is the percent, right? So it is in terms of a percent, not a decimal. So just be warned that you're not doing that conversion in this rare case. All right, so first thing, if the airflow is 35 liters per second, and that's in the range, so that's good, then what percent of contaminants are removed? So we're simply going to, let's do it down here, there's not really enough room in there. We're simply going to use this formula, the percent removed, 1.06 times our F, and our F, they gave it to us, the airflow, 35, right, liters per second, and then plus 7.18. So we simply just put that into our calculators. And so let me do that. So we do 1.06. Let me put it here so you can kind of see maybe. So I do 1.06 and then times 35 and then plus 7.18, and we get 44.28. So that means the percent is 44.28, and that's a percent already. Normally, formulas like this, we would get out of our calculators 0.4428, and then we would move the decimal for the percent. But this formula is kind of weird. It's a rarity that we use the actual percent, not the decimal. Okay, so this one. What flow rate, F, to the nearest hundredths must a range hood have to remove 70% of the contaminants from the air? So again, this time we're going to type in the percent as a percent, not as a decimal. So 1.06, and then this is the F, plus 7.18. And we want to solve this one for F, so we'll bring the 7.18 over. So we'll do 70 minus 7.18, and then we would divide by 1.06, and that should be equal to F. So we can take our calculators. We can put our calculators and we can type that in. So in parentheses, 70 minus 7.18, close that parentheses, and now divide that by the coefficient 1.06, and that gives us about a rate of 59. The flow rate would need to be about 59.26 because they asked us to go to the hundredth, and this is, I guess we should put down the units in this. This is liters per second. So L per S, okay? Liters per second. All right, and so the homework that I'm suggesting you do for this is from section 1-2 is numbers 12, 15, 18, 42, and 45. So work on those. Those are due next class.